Hey folks, welcome to the System Design Day 01. So we are going to start with the client server architecture. What is the image of client server architecture in your mind? If we talk about the request and response architecture, like we have a user, which is the client, and the client is going to send a request to the server. Server is going to process the request and is going to generate a response, and the response will be displayed on the screen of client. Like almost every web application that you use is built on this simple yet powerful concept called the client server architecture. On one side, you have a client. This could be a web browser, mobile app, or any other front end application. And on the other side, you have a server, a machine that runs continuously. Continuously means it is available to you 24 by 7, waiting to handle incoming request. It is always waiting to handle the incoming request. Once the request is received from the client, it processes it, and after processing it, it generates a response. Then it sends the response to the client. The client sends a request to either store or retrieve or modify your data. The server receives the request and processes it, performs the necessary operations, and sends back a response. This sounds simple, but there is a big question. How the client even know where to find the server? That is really important. Like, suppose I have a friend and I don't know his address. How will I communicate with them? I have a community. I don't know where to communicate with them. I should know the address, right? Here we have IP address. A client doesn't magically know where a server is. It needs an address to locate and communicate with it. On the internet, computers identify each other using IP addresses. So, like you have a computer A and you have a computer B. Computer A is going to send requests to B based on the IP address, which work like phone numbers for servers. As an example, we have this computer and this is the IP address. And we have this computer and this is its IP address. This computer is going to send a request to this computer based on this IP address. It knows the IP address of this computer, and this is going to send the request or any kind of message to this computer based on this IP address. These are the addresses. Like every publicly deployed server has a unique IP address. When a client wants to interact with a service, it must send requests to the correct IP address. But there is a problem. Let's discuss that. When we visit a website, we don't type its IP address. Like you visit excalidraw.com, you are not typing the exactly same IP address you have, right? So what we actually type, we cannot expect users or even systems to memorize a string of random numbers for every service that they connect to. Like in layman's term, if I talk, like we start reading ABCD and then making sentences. So if we talk about our audience, most of them are non-technical. They don't know about the numeric values, but they know about the easy words. And if we migrate our services to another server, its IP address may change, breaking all direct connections. Here comes the DNS. Instead of relying on hard to remember IP addresses, as we have seen earlier, we use something much more human friendly, which is called as domain names. So here the excalidraw is a domain name, but we need a way to map a domain name to its corresponding IP address. Like how can you ensure that excalidraw is mapped to the correct IP address to which we are looking all the content on excalidraw.com? We need a way, right? This is where the DNS comes in. DNS is nothing but domain name system. It maps easy to remember domain names like we have excalidraw.com to their corresponding IP address. In the domain name system, what happens is, in the form of tables, and in the form of a data structure. All the IP addresses are stored, and these are mapped to the domain name. Once you request for a domain for a IP address, it doesn't directly go to the server. It first goes to the DNS. Then DNS is going to provide you the domain name, which is mapped to that IP address, and then you are going to locate to the server, which is located at that particular IP address. Like at a start, we have a client. Client is going to send xcalidraw.com to the DNS server, and then we are going to get the IP address of the actual server where we have to send the request. We got the DNS, we got the IP address from the DNS server, and then this client is going to send the request to the actual server on which on this IP address it is located. Like here is what happens behind the scenes. When you type xcalidraw.com into your browser, your computer asks a DNS server for the corresponding IP address. Once the DNS server responds with the IP address, your browser uses it to establish a connection with the server and make a request. You can find the IP address of any domain using the ping command. Like you can go to your terminal or your command line interface, and you can type ping, and then after that just opening your terminal and typing ping followed by the domain name, and then it will return the IP address currently assigned to that domain. Next is proxy versus reverse proxy. So proxies and reverse proxies are the servers that sit between the client and the server to improve the security, privacy, and performance. Like what happens is there are so many hackers and threats in between the transmission of data. So we don't want to uh, release, or we don't want to show them the actual servers and client information. Here we use proxies and reverse proxy. A proxy server, sometimes also called as forward proxy, acts on behalf of client, while a reverse proxy acts on behalf of servers. Here you have, like we have user 1, we have user 2. User 1 and user 2 is going to send the request. It goes to forward proxy first. This is the client side, and then it goes to the internet. After reaching to the internet, then it goes to the actual servers. Okay, so forward proxy is put on the client side, whereas like if we talk about the reverse proxy, you have user 1, user 2, they send the request. First is it goes to the internet, and then after going to the internet, it goes to the backend. This is the backend part. So the reverse proxy is in front of the servers. Here the forward proxy is after the users, and here the reverse proxy is in front of the servers. Okay, what is a proxy server? Like if we talk about the forward proxy, a proxy is an entity that has the authority to act on behalf of another. In computer terms, a proxy or a forward proxy is a server that acts on behalf of client on a network. When you send a request, like opening a web page, the proxy intercepts it, forward it to the target server, and then relays the server's response back to you. For example, we have a private network in which we have two users. These are going to send the request to the forward proxy. This is a private network. Why? Because we have private information of the client here. Client information is not known to the user end at the backend on the internet. We have this private network, and the request goes to the internet, and after going to the internet, it goes to the actual web servers. Like the user information is still hidden because we have a middleman. We can say that we have a forward proxy act as a middleman, and that is going to send the request to the internet. Internet knows about the forward proxy, not the actual user. So here is the security concern. Like think of proxy server as a middleman that sit between a private network and a public internet. Let's walk through a simplified example of how a proxy server handle a request. Uh, the user types a website URL into their browser, for example, excalibur.com. The request is intercepted by the proxy server instead of going directly to the website. Here we have the forward proxy. The request first goes to the forward proxy and then it reaches to the internet. The proxy server examines the request to decide if it should forward it, deny it, or serve a cached copy. The server receives the request, processes it, performs the necessary operations, and then sends back a response. Like forward proxy does one more thing. If it has accepted the request of the user and has sent to the internet, then it is going to generate a acknowledgement like I have done this work and I have sent your request to the internet as a middleman. The server receives the request, processes it, performs the necessary operations, and then sends back a response. When the target website responds, the proxy receives the response and relays it to the user. So if we talk about the key benefits of proxy servers or forward proxy, first comes is privacy and anonymity. Proxy servers hide your IP address by using their own, like user address is not going to be sent to the actual server. It is the proxy which is going to generate its own IP address, and IP address of proxy servers goes to the internet and then to the servers. So the destination server cannot know your real location or identity. You are safe. If we talk about the access control, organizations uses proxies to enforce content restrictions, monitor internet usage. Like in my college, what I used to find is the upload speed is quite fast, whereas the download speed is quite slow. So they are actually using the proxy servers, and I cannot access the full internet facility at my college because what they do is like they ban you from accessing links like youtube.com. You cannot access that because they are using proxies. If we talk about the security, proxies can filter out malicious content and block suspicious site, providing an additional layer of security and improved performance as well. Proxies cache frequently access content, reducing latency and improving load times for website. If we talk about the term latency here, so latency is nothing but the time taken to round up, like the request goes from the client to the server and then the server responds back. So it is the time taken for this cycle. Okay. Is a VPN the same as proxy? So the answer is no, because while both hide your IP, both do the same work, they hide your IP. A VPN encrypts all your internet traffic, making it more secure. A proxy only forwards a specific request without necessarily encrypting them. What does a VPN do is when you send a request, so it is going to make a separate path for you, which is VPN are mostly premium. Like it is going to create a separate secure path pipeline for you, and your request is going to travel from the client to the server through that particular pipeline that you have purchased, or like you when you work in the industry you get a VPN. So that is the actual path you interact with your organization, but it makes it more secure. These both are not same. A proxy only forwards a specific request. Specific request in sense you can access www.google.com, but you cannot access www.youtube.com because there is a set of instructions already set in the proxy. And specific information, if we talk about, the IP address of the proxy goes, whereas the user information is hidden, completely hidden. That is why we are secure. If we talk about the real world applications of proxy servers, so the first is bypassing geographic restrictions. One of the most common uses of proxy server is bypassing geographic restrictions on websites and content, like streaming services, for instance, often offer different content based on a user's location. With a proxy server based in the target region, you can access that region's content library as if you were a local user. What happens is, like, I am in India, and I am accessing the content of some YouTuber in India, and my request goes to the nearby server. So what happens is, in between, proxy act as a middleman, and it says, okay, it talks to the server, and it says, okay, this request is coming from northeastern India. So it acts like I am sending the request from India. It doesn't says like, even my request is from USA, so it acts like I am sending the request from the same country, like India, where the server is located. There is a client in India, and that client is going to send a request. First is it goes to the proxy client, okay, and then it is going to interact with the proxy server in the US. So the proxy server is then going to interact with the streaming server in the US. This is how, like, actually the communication is happening between the proxy server of USA and the streaming server of the USA, whereas the request actually is going from the client of India. Then it goes to proxy client, then proxy server of USA interacts with the streaming server of USA. That is how the streaming server of USA thinks like the request is coming from USA itself. It doesn't know that actually the request is coming from India. Suppose you are in India and want to access the US library of a streaming platform, example Netflix. You are watching some movie, you are watching any kind of reel, anything. By connecting to a proxy server located in the US, your request to the streaming platform will appear to be coming from the US, allowing access to its content as if you were a US based user. Actually, this doesn't even know that your request is coming from India. It knows only one thing, that request is coming from a proxy server of USA, and it thinks like you are sending the request from US. If we talk about the speed and performance optimization, we are going to use caching. Caching is nothing like, it is storing your frequently used commands, and then you don't need to again redirect as a new request. Proxies can store cached version of frequently accessed content, enabling faster load times and reducing bandwidth usage. For example, we have a private network. We have a user 1, user 2. They are going to send the request to the forward proxy. And then if this request is not available in the cache memory, then the forward proxy is going to store to the cache memory. And if the same request comes again, forward proxy already know that it is already present in the cache memory. It is going to check that cache memory is going to provide that request information. Then it is going to send to the forward proxy, and then forward proxy is going to communicate to the internet. So it is saving the time, increasing the speed. Then it is going to interact with the internet, and then the request goes to the either web server 1, web server 2. When a user requests cached content, the proxy server serves the stored copy rather than that fetching it from the destination server, which reduces the latency, which is request response time. And to avoid stale content, it uses a time to live value, automatically expiring cached data after the configured time. Time to live is like, if you are frequently using that command, its time to live is more like, if you are not using, it will throw to the garbage and it will expire. Example, an organization with hundreds of employees frequently accessing the same online resources can deploy a caching proxy. This proxy caches common website in its database. So subsequent requests are served quickly from the proxy's storage, saving time and bandwidth. Let's say, take a real world example. What we do is we daily log in to a particular website. Let's say we do login to LinkedIn. So on LinkedIn, when I first type my password, I type my username, it is going to log me in. And then when I again go to the same part, I type linkedin.com, it is just going to send me to the feeds page. Why? Because the request is already cached. It is already stored and it is a frequently used request. So it is already stored in that memory. It just accesses it and then it directly redirects me to the feeds page. Okay, so the next is reverse proxy. Reverse proxy is the reverse of a forward proxy. It regulates traffic coming into a network. Like you have a rate limiter, for example. It sits in the front of the server, intercepts client requests and forwards them to the backend server based on the predefined rules. Let's come to the example. There is a user 1 and there is user 2. User 1 and user 2 are sending the request over the internet, and then the request goes to the private network. This is whole private network which is situated at the back end. In forward proxy, we had the private network in the front end. This is situated in the back end. We have a reverse proxy. Reverse proxy is going to generate an IP address of its own, and then on behalf of its own, it is going to send the information to the web servers. When the web servers actually respond to a particular request, then they are going to send the request to the reverse proxy, and then reverse proxy goes to the internet. Then the command or for example the response goes to the users. If we talk about the security concerns, so the information of server is not known. You don't know where the actual server is located. You only knows that client only knows about the reverse proxy IP address. Like think of reverse proxy as a gatekeeper. Instead of hiding clients from the server, it hides server from the client, because many times in the industry attacks are made on the servers to corrupt them, uh, to fetch information from them. Allowing direct access to servers can pose security risk, exposing them to threats like hackers and DDoS attacks. A reverse proxy mitigates these risks by creating a single control point of entry. We have the gatekeeper. Gatekeeper is only allowing those guys who have the ID card. Think like that. Entry that filters and regulates incoming traffic, all while keeping server IP address hidden. So the actual server IP address is hidden. Here we have the proxy, reverse proxy IP address, and that IP address goes to the client for interacting to them. With the reverse proxy in place, clients no longer interact directly with the servers. Even if they do any kind of attack activities, they are not going to know about the actual server address. They are just going to know about the proxy server address. Let's walk through a simple example of how proxy server handles a request. A user types a website URL into their browser, which sends a request to the server. The reverse proxy server receives the request before it reaches to the backend servers, exactly as we have seen in the diagram. And based on predefined rules, like you have load balancer. Load balancer is almost like a traffic cop who used to balances the traffic, incoming traffic, or server availability. It is also going to check that which route is free, so that I can manage the traffic to that particular route. The reverse proxy forwards the request to the appropriate backend server, whichever is free, to not doing the work or overloaded. The backend server processes the request and sends a response back to the reverse proxy. The reverse proxy relays the response to the client, with the client never directly interacting with the backend servers. We are actually interacting with the reverse proxy. Reverse proxy is generating its IP address, and based on that IP address, we are interacting with the servers. We don't know about the actual IP address of the main servers. If we talk about the key benefits of proxy servers, so enhance the security. By acting as a protective layer, a reverse proxy hides backend servers from the client. Client doesn't know about the information of where the actual location of backend server is, reducing the risk of attacks, direct targeting backend infrastructure, load balancing. A reverse proxy can distribute incoming requests evenly across multiple backend servers. Suppose you have backend server A, backend server B, and backend server C. So if backend server A and backend server B both are busy in doing their work, backend server C can handle the request, and that is known by the load balancer, the traffic cop. The traffic cop, like load balancer, is going to send or say to the backend server C, hey, can you handle that request? Yes, I can handle that request, and that is going to send that particular request to the backend server C. And it also prevents server overload. Obviously, the one, suppose you are the guy who is doing so many work already in an organization, and if your boss comes in and says, hey, can you do this as well, whereas your colleague is not doing anything, so how it will feel like to you? It is like a condition of server overload, right? If we talk about the caching static content, reverse proxies can cache static assets like images, CSS, and JavaScript, reducing the need to fetch these files from the backend repeatedly. SSL termination. Reverse proxy can handle SSL encryption, offloading this from backend servers. If we talk about web application firewall, reverse proxies can inspect incoming requests, acting as a firewall to detect and block malicious traffic. It is not only doing the work of hiding the information, but it is also acting as a firewall as well for the web servers. Let's come to some real world examples of reverse proxy. So Cloudflare's reverse proxy is widely used by the global websites and applications to boost speed, security in terms of reliability. Its web application firewall and DDoS protection blocks malicious traffic before it reaches to the site server, safeguarding against attacks and improving uptime. Cloudflare's global content caching caches static and dynamic content at over 200 data centers around the world, storing frequently accessed files like images, CSS, and JavaScript closer to users, because like you can see this web page, right? And you can see the images, you can see the CSS part, you can see the JavaScript running behind that. This all is cached. This all is a frequently used content, so it is already stored there. This significantly reduces load times and latency, as requests don't always need to travel to the original server. Like I've made these notes, you can see on my screen. So actually excalibur.com is providing me the cached part. It is providing me the frequently accessed files. It is providing me the already stored content. It is not going to the actual server again and again to access the content. Finally, we have a summary, like whatever we have discussed. We have discussed firstly the client server architecture. We have also discussed about the proxy and reverse proxy. We have discussed about the IP address. We have also discussed about the DNS. So if I talk about the features, like if I talk about the position, proxy servers lies between the client and the server. Whereas if I talk about reverse proxy server, it lies between client and multiple backend servers. There can be multiple backend servers like we have seen in the diagram or the architecture. If we talk about the goal of proxy server, it protects the client end identity. Like, we are going to send the request to the forward proxy, and then the forward proxy is going to generate its own IP address. Based on that, it is going to transfer that request to the internet, then it goes to the servers. And if we talk about reverse proxy server goal, so distribute request, load balancing, and protecting the servers. Use cases: privacy and bypass restrictions, load balancing, and server protection. Common users: individuals and security focused users who don't want to show their identity actually. Enterprise website with high traffic, because you can do DDoS attacks there. Examples, if we talk about, we have VPN services and browser proxies. And here we have Nginx, HA proxy, Cloudflare. This was all about today. We have discussed about client server architecture, what it is, like there is request, then we have response, we have a client, we have a server, and then like how do I get to know where to send the request. So here, like we talked about IP addresses. IP addresses are basically of two types. You might have studied in computer networks, like we have IPv4, we have IPv6, and then we talked about the DNS, domain name system actually. After that, we have covered what is proxy, what is reverse proxy, why do we need cache in the proxy and reverse proxy, and what actually cache do, how proxy is protecting the client, how reverse proxy is protecting the servers. And we have also discussed about things like what is time to live. So like if your request is frequent, then its time to live is more, whereas if you are not requesting for a long period of time, cache is going to throw the already saved request into the garbage. Okay, this was all about this video. Hope you like this. Do like, share, and subscribe my YouTube channel. And if you have any query, you can mention in the comment section. I will respond to that. Thank you.